This is the AMDM Semester 2 final exam review. Wanted to go over a few questions with you. The first question here says Chase is offered a permanent position, tells the annual salary, says he has the same salary each week. He is offered a job that now pays $20.50 an hour based on their gross monthly income. Which would you recommend? So you want to figure out the monthly income. So the first thing we want to do is take $40,000 and divide it by 12. And when we do that, we get a gross monthly income of $3,333.33. That's on job 1. The second job, where he makes $20.50 per hour, first you have to figure out his annual salary, so that'd be $20.50 times 40 hours a week, 52 weeks in a year. Then we want to take that and divide it by 12 to come up with the monthly salary. So this monthly salary here would be $3,553.33. So when you compare the two, you would recommend that he take the other job, since that's going to have a higher salary. Now the second question has to do with investments. There are two possible savings accounts Josie can have. She wants to invest $15,000. The first is in a savings account, and the savings account earns 0.05% interest, and it's compounded annually. The second is a CD. It does simple interest of 1.5%. Now the difference is in compounded versus simple interest. The formula for compounded interest, the future value is equal to the present value times 1 plus the rate divided by the number of times n that it's compounded per year, raised to the NT. Well, our initial investment is $1,500. We have 1 plus, and that you want to change 0.05 to a decimal, so that's 0.0005 divided by 1, and that's raised to the 1 time, and then she's going to save for 20 years. Now, the reason we're dividing it by 1 and raising it to the 1 is because it's compounded annually. So annually means you're only going to compound that interest once a month. Let me see if I can give myself a little bit more room here. Okay. So the amount for this case here, when you put that in your calculator and multiply that out, is going to give you $1,515.07, and that's with the compounded annually. Simple interest is a linear function. The formula is the future value is equal to the present value times 1 plus the rate times t, the number of times it's compounded per year. So in this case, it would be 1,500 times 1 plus, convert that 1.5 to a decimal, so 0.15, times 20 years. That's going to give you $1,950. So in this case, for a 20-year period, it would appear as if the simple interest CD would be the better of the two choices. So next we have one of those job scenarios. In this job scenario, what we have is a job that pays $44,000 per year. They would like you to estimate the monthly after-tax income. So you have to figure out what the taxes are. So the best way to do this, we have 15% plus 6.2% plus 1.50%, and that's going to give you a total of 22.45%. Now, if you take 100% and subtract the 22.45%, that's going to give you 77.35%. Actually, that was 22.65%. All right, so what we're going to do now is we're going to take that annual income and figure out how much is paid, how much you get after tax per year. So we're going to change that percentage to a decimal, and that means that you make $34,034, and that's your after-tax yearly. So to figure out the monthly, we simply want to divide that by 12, and you get $2,836.17. So that's your Unit 6 material on finance. Next, we have some Euler's paths and circuits. Here they want us to tell you a few things. It says, find the Euler circuit or Euler's path. If the graph has a Euler circuit, find one and label the edges in order in which you would travel them. If the graph has a Euler's path but not a circuit, find one and label its edges in order. Okay, so first of all, in order to determine, you have a path if it is only 2 odd degree vertices, and it is a circuit if all the vertices are even. To determine if I have a graph or a circuit, I'm going to find the degree of each one of the vertices. In this case, I have a degree of 2 because there are 2 edges, and then a degree of 4, 2, 4, and 4. Since they're all even, that tells me that this is a circuit, and that's a Euler circuit. As far as to number them, I could start here. I could go 1, 2, so I'm going here, then here, 3, 4, swing around, 5, 6, 7, and then 8, and that's how I could travel those. Next, I have a degree of 3, 2, 2, 3, and 2. Notice that only 2 of them are odd, so this means I have a Euler's path. If more than 2 vertices are of odd degree, then it's not a path or a circuit. As far as numbering them goes, in the order you would go, you could go 1, 2, 3, 4, 5, 6. The difference in the circuit and a path is in a circuit you end up at the same place you started, whereas in a path you just cover all the edges. Alright, so next it says consider the following map and containing the islands, and it wants you to connect them with the bridges. Let's see if I can. There we go. It's so does this graph of the map have a Euler circuit? So what we can do here to draw a map of the area. So what we have the north bank, we have A, B, and C, and then we have the south bank. And so what you want to do is make you have 1, 2, 3 connections here, you have 1 connection here and here. B is connected to the south bank, and then the north bank is connected to C as well as the south bank. So again, we want to go around and look at the degree. So this has a degree of 4, 2, 3, and 2. So since some of the vertices are odd, this is not a circuit. This would not be a circuit, and that would be because the south bank has an odd number of vertices. Part B says, if it has a Euler circuit, number the bridges. Well, it doesn't have a circuit. If it says if it doesn't have a circuit, fix it so it does. So what we do is, oh, and by the way, this has a degree of 5. So to fix it, you find the two odd vertices, so I have 3 and 5, and we draw another edge in it, and now they're even, and that's how you go about fixing it. So this next problem says a mail carrier is assigned a new section of town. Before heading out, he wants to determine the most efficient route that still allows him to visit each house and return to the post office without visiting the house first. It says find such a route on the map below. Okay, I'm going to actually move this down so we can see the map. We can now see the map and the question at the same time. It says that it wants you to find a route. You're going to go to the office, you're going to cover all of these streets, and then you're going to come back to the office. So there's tons of ways that you can go about this. You could do P to L to F to H to A to B to E, or B to T, etc., etc., and you could keep going as long as you ended up back at the office. Now it says if this route exists, explain why this type of route and what type it is. And the answer here that this is what they call the Hamiltonian circuit. Since the mail carrier has to go to each house and return to the office, but does not have to use every edge. So you can hit all of the houses, if you will. You can just kind of go like this, and imagine going around like this. And now I've hit every house, but not all the edges. Since I didn't use all of the edges, you'll notice, for example, we have edges here like between P and K and O and X that I didn't use. That's what makes it a Hamiltonian circuit. It would be a Euler circuit starting and ending in the same place if we also used all of the edges. Okay. Question number 7 says your company must run Ethernet in the office below so that all the office and high-speed internets are together. So define the most efficient route. Now to do the most efficient route, you have to have all the same dots. So 1, 2, 3, all the same vertices, 4, 5, 6, 7, 8, 9. To be efficient, you want to use the smallest one. So we're going to use this 1 first because it only has a value of 1. Then we're going to use this one because it only has a value of 1. Now not everything's connected, so now I'm going to choose to use this 2. And so I get rid of that 2 there. Then I'm going to use this 2. Notice I'm picking the smallest numbers first. And then I'm going to use this 2. Still not everything's connected. So now I've got to use some other values. So I'm going to move up to 3. Well, I don't need to use this one because I'm already connected to this point and to this point. So I don't want to use that 3. But I am going to use this 3 here so I can connect to that point. So I'm going to use this 3. And I have 2 values left to connect to. So I'm going to connect down here using a value of 3. And then the only point I have left is to connect to this point here. Now I have 3 choices. I can have a length of 4, 5, or 4. So I'll pick the 4, which is going to give me the most efficient route, and it'll cost